Okay, so thank you, Corey, to introduce my presentation because you were pushing for FLR and where we are with FLR. I worked basically Jinshan worked on this presentation more than me. I'm kind of user of. Okay. Yeah. Okay, no problem. I'm a kind of user of the FLR technology for some of our procurement here in EMEA. So I started to be interested because I think that FLR is a breakthrough for Lustre, not only to implement a technology that can improve latency-bound application, but also because in the long term, not now probably, avoiding the HA technology can give Lustre the ability to run in a different space, like the cloud, where in the near future, with the implementation of much higher bandwidth in the Ethernet network, probably the parallel file system with high throughput will be necessary. So I started to be interested in this project, again, starting from the HPC domain, but also to understand if it can be implemented in different domains. The possibility to use FLR is done by the basically implementation of PFL, the progressive file layout. So with the implementation of PFL in 2.10, we are now able to move this project ahead. And as Peter mentioned, FLR is scheduled to be implemented in 2.11. So you saw this slide from Andreas since a couple of LAD and LAG. Where we are at the moment is in phase 1. We have, as I already said, implemented in 2.10 the PFL. And in 2.11 we will have the possibility to have delayed writing mirroring. And this is what I will try to demoing in a few minutes. But this project is not stopping at this level. We are really want to move the FLR concept ahead for starting to think how to do the immediate writing mirroring. We will talk about our ideas on a policy engine, a light policy engine implementation, and the final goal also in order to make Lustre suitable for the cloud guys, implementing the erasure code for striping files. So it's an ambitious project and we are starting now, basically. For the phase 1 that will be implemented in 2.1, we plan to do a redundant read and partially redundant write. So basically, the reads can be done from multiple replica in a round-robin fashion. So this can speed up your performance. If you are reading, you can read an object from different OST. The client automatically, in a round-robin fashion, decide which OST you can use, or you can override these using policies on the file. The write is partially redundant. At the moment, if the OST is becoming unavailable, we need to wait until the OST is coming back. So we still need, for this reason, HA until we go for immediate replica on the right. It's not necessary to resync the entire replica. I will show you this in a minute. But the FLR technology intelligently synchronizes only the modified components. So now I will start a demo. The demo is not live. I recorded because you know better than me that live demo is not good. And it's a video. There is no Steve Sims in the video, so don't worry. So let's start with the video. Okay. So there are two options. I can talk, or we can listen to Jishan with a nice, relaxing music, but you get probably sleep. So I decided to go with the video and talk about this. I want to make this shorter. It's 30 minutes in total. You can download and do at home. But now let's go to the main part. So as you can see, we have a very simple Lustre file system. We create just for fun 2 files. This is an example, okay? It's not what you can get in the reality. We do this example to create 2 files and combine in one single file just because we wanted to create different data in this file in order to demonstrate to you the HA capability of FLR. Okay? In the real life, you have a single file that is mirrored. In this example, we create 2 files. As you can see, there is a new command in the set stripe that is coming from PFL. So with this -EOF, we are creating a single PFL stripe layout that is basically the entire, this means that the entire file is striped as normal, okay? We will have an example of a file with different stripe layout based on the sides in few minutes. So we create these 2 files. Okay, in the first file we put OST1 as content, and in the second OST2, and then we will create a mirror of, we combine the 2 files and we create a mirror of the 2 files. Let's go ahead. Okay, this is a new command that we created for support FLR. So basically, this LFS mirror create a mirror using 2 files. Okay, just an example. In this case, as you can see, the get stripe give you some additional information compare what you get normally. There is a new output called LCM mirror count. That is the mirror that you created, because we can do mirrors 2 ways, 3 ways, or many ways you want, okay? And in this case, as you can see, there are 2 objects in these mirrors. Okay, let's go. So as you can see, this is 2 objects. One is on the OST1, and the second is on the OST2. Of course, the number starting from 0. So, and the file, as you can see, is OST. The content is OST1. Okay. Now we are unmounting one OST1, and we drop the cache just in case. And as you can see, there is the content OST2. This is not, again, this is not what you can get in a normal life. It's just to give you an idea that we are now reading from the OST2. In your real life, you have one single file that is mirrored between the two OST, so the content will be the same, okay? But as you can see, even if you have one OST down, you can still access your file, okay? So now we are also unmounting the OST2. We drop the cache, and magically we can't access the file because of course we ran out of mirrors. Okay, so we mount again the one OST. Okay, and again we are in recovery. We need to wait until the recovery is done. And when the recovery is done, you can get again your data back, even if there is one OST that is still not available. We mounted just one, okay? So now we mount the second one. Everything is mounted back. And as you can see, okay, now we do another stuff. We add some data. Okay, we add some data to the mirror. As you can see, the mirror is still the same with 2, but we have another. Okay, we have this information. So as we already said, the actual FLR implementation is not immediate writing. So the writing is asynchronous. So we need to sync the mirror. So in order to do that, we have a special command. Of course, the data is in the first mirror, okay, but the second mirror is still not synchronized. There is a special command called mirror.io that Jinshan has created in order to dump the content of a mirror even if is in stale mode. So this is for debugging purpose only command that give us the possibility using the -i to dump the content also of an stale mirror. So we can see what is in the dump the mirror 2, that is OST1 2, and in the mirror 1 there is OST1. So as you can see, there is no synchronization by the two. So now we need to do the synchronization part. Let's go. Okay. So this is the command that we can use to synchronize. Is a new LFS mirror, has this Resync. With the Resync, we are synchronize the part of the component in the file that are out of sync. So at this point, as you can see, the stale status of the second mirror disappear because at this point the two mirrors are in sync. Okay, so let's go on the second. I don't want to go much into that. Let's go in the second part of the test. Now we are creating a different file. So let's talk a little bit about this command. So this command gives you the possibility to create a three-way mirror, -n3, and this is a PFL component, a PFL file that from 0 to 1 megabyte has a layout, and from 1 megabyte to end of file has a different layout. Okay, so it's a single file, three-way mirrors with two different components. The first component between 0 to 1 meg, and the second component is 1 meg to end of file. Let's see how this look like when you do get stripe. Okay, so as you can see, there are three mirrors. Okay, here there is the first mirror that is from 0 to 1 megabyte, and the second one is from 1 megabyte to end of file, and you have three of those. Okay, so this is PFL plus FLR all together. Okay, so the file is one. There is nothing inside the file at this point. We inject some data into the file. So we inject this GPL header into the file, as you can see. Okay, so we use DD to create the file, and as you can see, the file, the content of the file is exactly this text file. Now, if we go to again to LFS stripe, we see that we are using, due to the fact that the content is very small, is under 1 megabyte, we use only the first part of the component, between 0 and 1 megabyte. The 1 megabyte to end of file is not used. So as you can see here, the EDX number, and we don't have anything here. Okay. Okay, so let's go ahead. There are three, of course, mirrors associated to OST 0, 1, and 2. Now, one second, let me stop for a second. As you can see, when we inject the data into the file, okay, only one of the three mirror is has the data. All the other are in stale status. This means that are not sync. So when we do the resync, we only sync the component that are not in sync. We are not sync all the file. Okay, and this is very important, because if you have a multi-terabyte kind of file and you are changing only the first part, the first megabyte, you don't want to sync everything. Okay, you want just to sync the component that is out of sync. So this is basically, I think, the last part of the demo. Yes. I think so. Okay. Yes, we demonstrated that after the sync, all the mirror are in sync, and the file is as we already saw. So with the mirror IO dump, I can see the content of each of the mirror again. So this is what we have today, what you can expect in Lustre 2.11. So let me go back full screen. Okay, so this is what we get from today. So as you can see, between FLR and PFL, we can really use this technology and start to think about multi-tiering for Lustre, because of course you can set up on the first component between 0 and 1 megabyte a pool of SSDs, plus for the bigger part hard drive. So it's very these two technology combined make Lustre more flexible in this respect. But the problem is how we can manage that. As already Cory said, we needed to have some tool, and we needed to have some automatization in this respect. So now I would like to discuss with you what we are thinking for make this happening, especially for the bus buffer use case. The bus buffer technology is something that we talk since some time. We saw some interest in the market. We saw some interest in end user to start to implement, also because the 3D NAND technology is becoming more and more attractive on a cost perspective. Intel itself is ramping up in terms of volume of 3D NAND technology that we are shipping on the market. We are also providing a new technology called 3D XPoint. So there is a lot of interest to move cold storage to the 3D NAND, and also to implement something more close to the computer node that can protect the computer node from latency bound application. And we are thinking about how FLR can be implemented as a bus buffer technology. So why we want to do that? Because first of all, Lustre is a proven technology, and as you see from the previous slide, the previous presentation, Lustre can be used today as POSIX parallel file system with flash technology. Even if it's not solving the problem of very high, very sensible application on latency, but is a great improvement. The possibility to have a unified namespace is also important and for customers. So in this respect, FLR can be a valid solution. The problem is how to manage the migration of the data between the OST bus buffer and the OSTs that are with spinning disk. At the moment, the LFS mirror Resync that high performed in the video, or G-Shock performed in the video, was running on a client. And this synchronized on the client side. So this means a lot of I/O going to the client, and this is not acceptable, right? So we need to do other things. And based on the some procurement that I'm working on, the bus buffer capacity should be at least 3 times the total amount of memory that you have in your cluster. Okay, so with clusters that now are large and the number of channels are increasing. So with Skylake we have 6 and other vendors are proposing 8. So the amount of memory that you have in your cluster is becoming bigger and bigger. So the bus buffer must be bigger and bigger because at least you need 3 times the memory size. So a proposal to manage the bus buffer and is to use, of course, a policy engine. But we need a more lighter policy engine compare what we have with, for example, Robinhood. Because Robinhood is targeting a different kind of job, okay? An accounting job, a more complex activity with a lot of information about the behavior of your user on your file system. Instead, this should be something very, very light that is not impacting a lot the performance of your file system. So the proposal is to go with object inventory file to maintain the link between the list of FID on the host in the MDT. So this could be not a big implementation task, but can solve some of the problem that we have with a fully policy engine. Even if this is not replacing the activity of a policy engine that need to maybe can be used in parallel. So another problem that I already mentioned was the synchronization that at the moment is on the client. The idea is to move this on the server, creating server local client that really just push the data from one tier to another. And in order to do that, and of course the benefit is decreasing the network bandwidth, especially if your design is, as we saw previously, with some I/O node from the computer node, from the computer fabric network and the storage fabric network, okay? So if you have the possibility to push everything on the storage fabric network, you can downsize the number of I/O nodes that you need for the data pushing. So the idea here is basically using the proposed MOI, the server-side client, to create some policy engine daemon that are running on the OSS side that basically are communicating with the PA policy engine master daemon on the metadata target in order to push the data from one tier to another. This is in a very light way, implementing only the necessary information that give us the ability to manage this kind of process. So I don't know how much I have, but I really believe that the FLR technology is a breakthrough for Lustre. First of all, because this will modernize Lustre in a way that can be used not only for HPC, but also for the cloud, or HPC on the cloud, because this is something that people want. They want to have the ability to have a multi-tenancy environment and a very fast parallel file system in this environment. And I think the FLR technology with the possibility to have a file system level redundancy give the possibility to do that. The other option is auto-tiering, having the possibility to really decide a more flexible storage environment with Lustre that is acting as a data storage manager, not only a file system, but to improve the possibility to move the data across the tiers. And in the future, erasure code is really what we are thinking in combination with the amount of instruction that we are feeding into the CPU as Intel. We have the possibility to leverage this new instruction to do a very fast erasure code algorithm. I hope, I was astonished 1 year ago when we started to talk about implementation of the DNE project, when DNE was released 2 or 3 years back. I hope that for FLR the adoption will be faster. So as Intel, we can have more feedback from the end user in order to improve this technology. I hope that really the community will start to play with that, and the vendor, can create crazy stuff using this technology, because yes, it's a very exciting technology and it's work, as you saw from my demo. So this is my last slide. Any question?
Hi. Can the mirrors have different layouts?
Sorry?
Can the different mirror copies have different layouts?
Yeah.
So you can have, for instance, different stripe sizes between different mirrors? What about?
Each is completely independent, as you can see.
So then how do you copy, for example, data server side from, you are syncing individual components, right? So how do you marry up components between different mirrors with different layouts? So
basically, for component, you mean the PFL component, right?
Sure.
Okay. So for example, if you have, so the mirror is the same, is global, okay? So if you have a three-way mirror on a single file, you have 3 mirrors of each component. Each component can have a different stripe layout. So let's think about RAID 10 or RAID 50, okay, kind of stuff, okay? So I don't see any problem to have a different striping.
Well, let's say you had a PFL for the first mirror copy,
yeah,
and a straight,
no, PFL is for all the file.
So so they have to be the same layout.
I can answer this more clearly.
Yeah.
So the server local client is still going to be able to understand the Lustre file layout, right? So it will be reading from the local OST and then writing out. I mean, it may in the case where you're describing where the stripe count or the stripe size is not identical, it may still have to do network I/O, right? But in case
to pull in data from a different OST.
Yes, yeah, but it can still run entirely on the storage network. And in the common case where, let's say, you have a single stripe file because that's the most efficient anyways for most uses, you would be doing one-to-one, and it would be the optimal case, right? It's only if you're doing things like, you have 56 flash OSTs and 237 disk OSTs or whatever, right, where you may have to restripe, right?
Okay. I had another question, which is, can you change the primary copy, like kind of dynamically, so you can choose to
Yes.
Yes, so this is the thing about having, for example, the primary copy on a pool that is SSD based and a secondary copy on hard drive. So the idea is, okay, I start my job writing on the SSD pool. I do a synchronous copy on the hard drive, and I remove the SSD one when I'm done.
So that was going to be my last question. You can remove one of your mirror copies arbitrarily after you switch the primary.
This is the idea.
Yeah.
This is the idea. And also do the other way around. Maybe work with a scheduler to pre-stage. Okay.
I have one more question. How about some semantics when some client writes so many bytes at the time, so the OSs are down, and maybe a client reread. So what's the semantics of such kind of?
Well, as I already said, at the moment, if you have your writing going in a OST that is having a problem, you need to wait until the OST is coming back. Yeah. There is no protection. But when we are starting the phase 2 of the project and we have an immediate writing, we are thinking about how to manage, the writing protection on OST that are not available. At the moment, is one of my first bullet.
I was just wondering about, like, if you wanted to kind of have very custom or very complicated mirror locations, like whether you have any ideas of, say you actually had some kind of layout map of, you wanted to actually ensure that objects were on particular racks even, or you had maybe OST pools perhaps, so you ensure that your mirrors are in particular kind of physical locations.
So there's, as part of PFL already before FLR, you can, specify pools on a per component basis, right? So, the beginning of your file, like with data on MDT, actually the first part of your file can be on the MDT, and then if it grows larger, it would automatically spill onto, say a different OST, your flash-based OST, and if it gets huge, you would say you have to write, once it's past, the size of the burst buffer, then you have to write to the disk pool directly, right? So that's okay. One of the things that we wrote, and it's in a patch, it hasn't landed yet, but is the ability to use another file as the template, right? It will generate a YAML. Either you can save the layout into a file and just say, use this YAML, template as the layout for every other file, or you can just point to another file and say, use this other file as the layout. So you can do something complicated and then clone it many times, right? But that, we haven't landed that functionality, it just needs some review and stuff.
I've got a question regarding what you have presented regarding policy, burst buffer policy engine. Is that just ID, or there is already some designs? Is something you are working on? Just thoughts for now.
No, I think Andreas and Jinsha, you were
just
discussing that. So if there is any feedback, or if you want to collaborate in that, more than happy to do that. It's not really a policy engine in the sense that we are not storing any accounting information. It's just what really needs for the purpose of tiering, right? But we are open on collaboration and co-design in this aspect.
Okay.
Any other question?
You said that when there is a component which is stale, only this component will be updated. Does that mean that the whole component will be updated, or does only the range which was modified will be updated?
The component, so the PFL component. So this doesn't mean that we are just updating 10 bytes of the file, okay? Or if you have a file that is one component only and is 1 terabyte, we sync everything. But if you have a file that is split as in the sample between 0 and 1 meg, and 1 meg to the end of file, and the part modifies only the first 1 meg, we resync only the 1 meg.
Okay, so this is the whole component.
Yeah.
Yeah, I mean, this is, again, it's, this is phase 1, right? We had to cut down, as much as we can just to get something that's working, right? And it's not going to solve everything. So resync, is something that can be done. Like right now, the resync LFS, mirror resync command, it's a single-threaded command that runs on one client, right? But if you have, parallel data movers for HSM and things like that, and you can do these things in parallel in user space much more efficiently, right? So then separately from that, we discussed, are you going to have something like a dirty bitmap, or would we, one of the things that came up in discussion yesterday was having a PFL layout that's self-extending, essentially. So you'd say, every 1 gigabyte or 16 gigabytes or something, you get a new component, right? So that would put an upper limit on how much needs to be resynced if you have a large file, right? And so, that again, it doesn't exist. We just wanted to get something that's useful, and there's many, many different ways that we can optimize these things as time goes on, but better to, in my opinion, it's better to have something that people can play with, or it works for some use cases, even if it's not the best possible thing that we could have.
Okay. Thank you, Gabriele.